Hello and welcome back to the lab. Today on the bench we have a bit of Q&A. I got some comments on a previous video, which some are justified, absolutely, especially since the video release got uploaded out of order. Not really sure how that video got so far behind in queue, but it did. So here we are, and that probably explains some of the confusion. But I released a video recently that I was titled Messing Around with Null Meters and Finding a Source of Truth for the Lab for Now. Aptly named title based on the activity we were doing, but taking that video in and of itself without some background context can be very confusing, and I totally understand the confusion with what we were doing in that video. So this video is to help explain that video, but also to give you guys some continuing processes on how some things are going to move forward, and what we're doing to spin up the capabilities of the lab even further. If you guys have any comments, suggestions, things like that for the goals, absolutely hit me up in the comment section down below. I love reading everybody's comments, and everything, especially with this community, is incredibly insightful. The goal at the end of the day is I have two Fluke 5200As that need to be calibrated. We repaired both of those in a previous video. They're working just fine. Actually, they're still open on the floor off camera that way. I need to put some covers back on there and get them aligned and calibrated. They had some big power supply repairs done, things like that. So absolutely, they need a bit of calibration and adjustment. I've also heard that especially with modern gear nowadays, with what's accessible, the calibration spec can really be tightened up on those units. So I'm looking forward to seeing how well we can get that done. The problem is those are AC units, and calibrating AC is a lot different and more complicated and a bigger pain in the butt than calibrating DC. But we always start with DC. Well, at least most calibration routines do. Tektronix PG506 is a great example of that. You actually turn off the square wave and let it output straight DC, and that's how you do the calibration of that unit. You check it on DC, then you flip the square wave on, and you know it's calibrated on DC, or it has a known amplitude, I should say. So what the heck were we doing in that previous video? Well, in that playing around with null meters video, we were colliding the DC references against all of themselves using the Keithley 7510 as a kind of transfer standard. So with everything all warmed up, everything processing the way it should, taking measurements very quickly one after another, we could take relative measurements based on the DC standards. Pull you guys back and show you some of the secret underworkings of the bench that don't make it on camera very much. Even though I have a great lens on the front of this, it's just not wide enough sometimes for these shots. For those that are curious, that's an isolation transformer. Not used. There's an identical one back behind here, which has that's actually where the transformer is for the isolation supply for the bench. This is a non-isolated power strip that's just useful for the bench. And then we have the 7510. Current calibrator, older DC calibrator, and the 5440, the current king of the lab, so to speak, for DC accuracy. It's really a toss-up between him and the 2720 GS. Absolutely, the Fluke's winning right now for stability because I don't have all the references in the 2720. When I get all the references up and running, stability-wise, at least from the data sheets, from what I've remember, they're relatively close in comparison to stability and accuracy on the datasheets, which is great, especially since the 2720 has a null meter. I do not believe the 5440 has a null meter, so that can be highly useful. Over to the other corner of the bench, the two AC calibrators that I use, the 5200A and the associated amplifier. That's the 343, 2720, and the 1030G. There's another Fluke hiding back on the parts shelf that's behind that rack that I do need to get to the bench. That does need a very full calibration, as we found out when we did the calibration video, that absolutely needs to be looked at. So, where were we at for DC accuracy? Well, the 343 was what my primary source was in the lab very early, before I came into the 5440 and the other Fluke calibrators that we repaired in previous videos. And it's been a wonderful supply. It checks well with the 7330, so I had reasonable confidence in it that it was set and ready to go. It did not need a calibration, and I checked it every once in a while. And to the limits of the 7510, it was fine. And that's the key, to the limits of the 7510. So the 7510 is not a metrology level meter. It is a 7.5 digit DMM. It is a very capable meter by every stretch of the imagination. It is not, however, a Fluke calibration DMM or a 5383A, the 8.5 digit HP. Now, I've been into some instrument repair labs, things like that, that have absolutely had that as their highest reference in the lab, but they worked on stuff like this. So they worked on 3.5 digit DMMs, maybe a couple of 4-digit DMMs. In that case, a 7510 at 7.5 digits is plenty of accuracy to do those alignments and calibrations, and it's not necessarily a problem. The problem gets into when you want to start checking some of these way more accurate meters. It becomes somewhat difficult to validate. And actually, as we get past, well, not much goes past 8.5 digits at the moment. You do end up in Josephson junctions eventually. Absolutely, we cannot afford that here in the lab. Josephson junctions are a whole nother class of standard, and actually they are the current definition of the volt. The purpose of that video was not to see how close I was to the current definition of the volt. It was to see which calibration units agreed with each other and which needed to be adjusted to agree with each other. And then taking the three that agreed with each other, pseudo-averaging them. I did not average them. But looking at their deltas on the 7510 to the limits of its accuracy, picking the best one and moving forward from there. This let me set a base plane of DC accuracy here for the lab, at least as the best we could measure it for right now. This is always improving, and you guys are along for the ride, so as it gets better here, you'll figure out how we're doing that and what we're doing to do that. This guy, even after the rebuild, was in really, really good alignment with the 5440. I did have to do a little bit of work on the 5440 as well to get that up and running. I don't think I did a video on that. I have another chassis of a 5440. So if you guys want to see me do a restoration, the other chassis has a lot of problems. It will be an extensive rebuild of that unit. There's power supply problems. It goes into protect mode. It dies. The display's dim. Like there's a lot of work that needs to go into that one to get the second unit up and running. First unit's running just fine. The 5440 agreed with the 343, which was my base standard, and it agreed with the 3330, which is also pictured here. So we had three standards that were within tolerances of each other, relatively close. So that's how we settled on the 5440 being the base of the lab so far. Obviously, it still needs to be validated. It can be validated to the calibration and the accuracy of the 7510, which is all I needed at the moment. Might need to be tightened up. Don't know yet because I can't get that extra digit without some better equipment, better meters. Those meters, new, start at the 5-figure mark. So calibration level 8.5 DMMs, they go for base models start at about $10,000 and go up from there. We're starting to get into, well, not starting, we're well into the spicy gear in terms of price point for some of that. But if the channel grows enough and things like that, and there comes a need, and the need overrides the price point, one of those may show up on a bench. Don't know. Don't know what the future holds. Didn't think I'd ever have a rubidium standard here in the lab. Here we are. Yeah, the lab's grown kind of wildly. For those who have been here from the beginning, have seen the process and seen what it's taken to get the lab to this point. The lab was pseudo-established prior to me turning on the camera for YouTube and kicking some things in gear. it has been a lot of fun getting all this gear up and running and things like that. Sometimes you do want to tear your hair out and I have to walk away from the bench and go, I will figure this out tomorrow. Tonight is not the night. And usually I come back and what I was missing jumps out at me and lets me continue. All of that being said, gets us to a base of DC. It also told us that these two were very broken. The 73 or 2720 and the 1030 are absolutely dead. And, well, not dead. They were out of calibration and absolutely needed an adjustment. We had a pot-based alignment on that one and a digital-based alignment on that one where we just plugged in some sources. It did some math internally and accuracy popped out the other end. And we knew that the 330 was way out and needed to be worked on. So, DC is set. We got DC really well dialed in here in the lab. Everything's good to go for DC. Next steps, so obviously the goal being to calibrate a 5200A. Almost said 5205. I have to get the Ballaston validated and calibrated. And I needed a very, very solid DC source to do that. So hence why we went through the round robin and figuring out which sources I could trust, which sources needed adjustments. Jumped into some of those adjustment videos. And that brings us to today. Once I calibrate the Ballaston and or get the Fluke version of a thermal transfer standard, so remembering what RMS voltages are, RMS is the same as a DC voltage of the same voltage heating something. The heat dissipation of the AC wave. Okay, how do I say this? True RMS voltage has the same heat carrying power as a DC voltage of the same voltage. So 10 volts RMS, even though it is not 10 volts peak to peak, there's more, it's a little bit lower than peak to peak, has the same heating potential as 10 volts of DC. This is really convenient for calibrating a RMS source, is we can use a thermal transfer standard, which is a very accurate thermal component that takes the AC, converts it to heat. The heat is then measured and outputs through a calibration and everything like that, outputs a DC voltage that we can then measure very accurately. That is what the Ballaston does. So the Ballaston 1600 is an automatic thermal transfer standard. There is a Fluke version, which I might add to the lab as well. It depends on if I can find a service manual for the Ballaston 1600. If I can find the service manual, we'll get that aligned up, calibrated. Once that's all checked in, then we have a known thermal transfer standard. Then we can go to a 5200. Then we can go to a 5205. And the 5200 is going to need the rubidium source plus the thermal transfer standard for amplitude, rubidium for frequency. And then finally, we will have an AC calibrator that is then calibrated in spec and ready to go. I actually have not calibrated these guys. So I've been using these for those that maybe have seen that video. I think I did a video on these. I bought these. Magic Smoke released from the United States Air Force. I actually still have the shipping container and things like that in the garage because it was a really cool fiberglass rack thing with rubber shock absorbers. I have some plans. I might do some things with that. I'm not sure yet. They sold it known smoked out for a very attractive price, especially because it had the amplifier, the controller, and the interconnecting cable. For those who saw that video, we did have to rebuild the 5200, but we did get it up and running. So what burned out there didn't really affect the accuracy with it. We did check the accuracy on the 5200A versus the 7510. Found it to be adequate for what we were able to measure, but I'd really like to get all of them calibrated and set up. They're pretty much aged out, so they're kind of done drifting at this point. That's a benefit of some of this older gear is it doesn't move around near as much as the new stuff, so all the components have really had time to settle. Everything's there, so if you don't have to do too much, especially on the calibration level gear, if you don't have to do too much repair to them, they tend to be very, very, very stable with time as long as nothing goes catastrophically south, which it did on that unit. It burnt down one of the spicy power rails. So ultimately, the goal is to get the 5200As calibrated because I do have, actually I have two functioning controller units now. I have an interconnecting cable and I have another power amplifier. The power amplifier I have tested. It does work. It needs power cords. They're very, very bad. If there's interest there, I might do a video. Hit me up in the comments down below. I might do a video on that. That is getting into spicy voltages. There are 4,000 volt supplies in that unit. There are 4,000 volt supplies with a lot of current directly into filter capacitors. We are dealing with some very spicy power electronics in that particular amplifier. Now, that goes without saying. What that 5205 is a fixed, I believe it's a 100X amplifier. It's either a 100X or a 10X amplifier. I don't remember which one. I think it's a 100X because they use the 10 volt rail, or they use the 10 volt setting from the 5200A. So whatever goes into the front end gets magnified 100 times. So you put 10 volts in, you get 1,000 volts out. That amplifier is capable of doing 1,500 volts on the output peak to peak. So to do that, it's got to have some pretty hefty supplies in it. It is incredibly heavy. That unit is bench-breakingly heavy. And most of it is transformer. That transformer can source a lot of current, and it's not something that I want to go. Even I'm experienced working with some high voltage stuff. I have experience working with CRTs, things like that. I'm comfortable around kilovolts, multiple kilovolts. I don't like taking the covers off of that thing if I don't have to. So we can do the work, absolutely, but it's one of those where everything stops, full focus, things like that, because things go sideways when you have that much, that high a voltage plus that big a current delivering capabilities. They go sideways really, really quickly, and we don't want it to go sideways through any humans. Those are some plans, a little bit of explanation as to what we were doing in one of the previous videos. And the goal ultimately is to calibrate some 5200As. So if that's interesting, hang around and let me know what you guys think. If you guys have a good way to get to a calibrated 5200A, let me know in the comments below. Absolutely look into all the suggestions. So with that, thanks to all the Patreons that help keep the lights on here in the lab and videos coming up to YouTube. Thanks for all the questions. If the questions get enough traction, you might see a video just like this one. If you like what you're seeing and want to jump down this calibration metrology rabbit hole with me, do all the YouTube things like share and subscribe, hit all the buttons, and hang around. As always, I read all the comments in between videos, and I will see everybody in the next video.